Right, we're beginning our discussion now looking at a part of mathematics called trigonometry, and we spent a significant amount of time on this. We did some time back, a few days ago, but we're going to actually continue to spend a bit more time on this. Okay, now, point P with coordinates x and 24 is a point. Here it is. And this point has coordinates x and 24. OP actually is 25 units. ROP has the size beta, is an angle. Calculate the value of x. Calculate the value of x. We need the value of x. Right, this is very, very easy. Who can suggest what do we do here? Anyone? Okay, I'm giving you 2 minutes to find the value of x, please. 2 minutes. And you tell me what it is. Okay, you tell me what it is. You done, Senulu?
No, sir.
Okay, let me know when you're done. I want to know the value of x. I hope you're able to see the question, right? All right, we just need the value of x. How do we find the value of x? Pegalelo, are you done? Okay, Pegalelo's mic might be off. Who is this one? Tando, are you done? Yolande. Yolande, are you done? Okay. Okay, yo. Tando, you done?
No, sir.
Okay, let me know
Awesome.
when you're done, when you got the value of x. Yeah, Tando is like he's saying something. Tando.
I got 7.
You got 7. Let's check Tando.
Negative. Sir.
You got -7. Okay, that's fine. Let's take a look. Right, so at this point, we perform a construction here. Meaning we have that if you perform a construction, this is x and this is y. So y is 24. And then if y is 24, we then will proceed to note that our x is here and our 25 is the length of the hypotenuse. And therefore now we can use Pythagoras theorem, which is x squared plus y squared equals r squared. So the solution is as follows. So we present the solution to this question. Right, in presenting the solution to this question, we use x squared plus y squared is r squared, which is Pythagoras. Okay, what is x? We have x as it is, but we can see that y is 24 squared, which is r squared, which is 25 squared. You can write like that. It's acceptable. We can even remove this, yeah, like so. Okay, now we continue to solve this problem. And we have x squared equals, what is 25 squared? So this becomes 25 squared minus 24 squared. Okay. So this is x squared, you take the square root. And then you have 49, you take the square root. You take the square root both sides, and now this will actually become x squared is plus or minus 7. Okay, because the square root of 49 is 7. Okay, so there's no square here. Right, and as a consequence, hence we have that x is minus 7. Why? Because x is on the negative side. X is on the negative side of the origin. It's on the left side of the origin. And on the left-hand side of the origin, we know that x is negative, and we found the value of x. X is minus 7. So, yeah, okay. Tando was indeed on point. Let's look at the next question. The next question is as follows. Right. The next question is question 2. And here we say find without using a calculator. Right, in 2.1, we have the trigonometric sign of beta. And then we shall continue and look at 2.2. We have the cosine of 180 degrees minus beta. Like so. Okay? Now, let's look at the diagram. Want to find sine beta from the diagram. Let's check the diagram. This is the diagram. You want to find sine beta. Anyone, what is sine beta from this diagram? The numerical value of sine beta from this diagram. What is it? Anyone? Anyone? What is sine beta? The sine of beta, this one. Sine beta from the diagram. Anyone?
So it is equal to 24 over 25.
It is opposite of hypotenuse, which actually is 24 out of 25. 24 out of 25. Well done. Right, so we're looking at 2.1, the solution to that. The sine of beta is 24 out of 25. Right. 24 out of 25 because we're using SOHCAHTOA. Okay, let's look at the next thing. 2.2. 2.2, want to find the cosine. The cosine of 180 degrees minus beta. In which quadrant is 180 degrees minus beta? Anyone? In which quadrant is 180 degrees minus beta? Anyone?
It is the second quadrant.
This is the second quadrant in which the cosine is negative, because the second quadrant is only the quadrant for the sine. So the cosine is negative. Cosine beta. Okay, now let's look at cosine beta here. Cosine beta, so this is adjacent over hypotenuse. Adjacent over hypotenuse. Okay, and we have seen that x is minus 7, so which means that it is minus 7 over 25. Okay, so there is a negative in front. And you have minus 7 out of 25, which is 7 out of 25, like this. Okay. Right, you note this one. The next one is 2.3. Want to find the tangent of minus beta. What is the tangent of minus beta? Solution. Okay, what is the answer here? Okay, the tangent of minus beta. In which quadrant is minus beta? In which quadrant is minus beta? Okay, we do this. 90 degrees. Okay, we start here 0 degrees. Minus 90 degrees. Minus what? 80 degrees. Minus 270 degrees, minus 360 degrees. So now if you look at this one, minus beta is the same as 0 degrees minus beta. Is a negative angle measured in a clockwise direction from the 0 degree ray. At this point, we are seeing that by using the cast rule, in this quadrant, you have that the cosine is the one that is positive, and therefore the tangent is going to be negative here. Meaning the tangent of minus beta is therefore negative. And what is the tangent of beta? From the diagram, what is the tangent of beta? Anyone? Because you already know that x is minus 7. So from the diagram, what is the tangent of beta? Anyone?
It is 24/7, -7.
Good. So because we know the tangent is, according to Soka-Tower, the tangent here is the opposite over adjacent, which is 24 over minus 7. So this is actually 24 over minus 7. Right. And now if you multiply everything here, it is 24 out of 7. Okay, next question. Okay, at this point now we want to find something else. Here is another question. I'm going to call it part 3. T is a point on OP such that OT is 15. Determine the coordinates of T without Right, without using a calculator. Without. Without using a calculator. Okay. Okay, T is a point on OP such that OT is 15. If OT is 15, determine the coordinates of T without using a calculator. Okay, let's see. OT is 15. Let's look at the diagram. You have that OT is 15. Then want to find the coordinates of T without using a calculator. If the distance from here to there is 15, what do we do right now? So right, so we have obviously exactly that part there. What do we do here? So we're going to find the sine of beta. And the sine of beta is what? Is opposite of hypotenuse, and therefore it is 24 out of 25. But the sine of beta is actually the same also as it is at this point here. The sine is opposite of hypotenuse, so it is 24 out of 25. Even here, it's going to be exactly y at t over 15. Note that. So it's the sine of beta. It is 24 out of 25. Which is like y at the point t divided by the hypotenuse of the point at the point t, which is 15. And if you have this is 24 out of 25 equals that. 24 out of 25 equals y sub t out of 15. Which is 24 out of 25 times 15. Right, if you use a calculator, you realize that this is exactly 14, remainder 2 out of 5. Okay, but also if you use the cosine here, cosine of beta is adjacent over hypotenuse, which is minus 7 out of 25, but also it is actually the adjacent at the point here, at the point T. So let us do this. So which is xt, yt. Cosine beta. Okay, you have cosine beta. Adjacent is the x, which is minus 7 over the hypotenuse, which is exactly 25, which is the same also as x at t over 15. x at t, so you cross multiply here, which is minus 7 out of 25. 15. So, which is minus 4, remainder 1 out of 5. The conclusion hence is therefore that the coordinate of t would be the x at t. X at t, which is minus 4, remainder 1 out of 5. Y at t. 4, 14, and 2 out of 5. Fourteen and 2 out of 5. So we continue. The next thing now is to determine the value of the following expression. Right, so we need to determine the value of the following. Of the following expression. You have two signs. Cosine x. The tangent squared divided by 10x. Okay, what do we do here, anyone? What do we do here? What do we do? To determine the value of this expression, we must write the tangent in terms of sine and cosine. In terms of sine and cosine. So this is equal to 2 sine x cosine x into 1 plus the tangent squared is the same as sine squared x divided by cosine squared x. We divide everything by sine x over cosine x, because the tangent is sine x over cosine x, but the tangent squared becomes sine squared x over cosine squared of x. Right, we continue right now. And if we continue here, we proceed as follows. We can just proceed by writing 2 sine x cosine x into 1 plus sine squared x plus cosine squared x, then you multiply by the reciprocal. So this equals 2 sine x cosine x into 1 plus sine squared x over cosine squared x. You multiply by cosine x over sine x. So you reciprocate this, it becomes cosine x over sine x. Right. What do we do here, anyone? So this becomes 2 sine x cosine x. We take here the lowest common denominator, which is cosine squared x. Cosine squared x divided by, so you can write this one out of 1 like this. Cosine squared x divided by 1 is cosine squared x by 1. Cosine squared over cosine squared is 1 sine squared. Multiplied by cosine x over sine x. Cosine squared plus sine squared is equal to what? Parallel. Cosine squared x plus sine squared x is equal to what? Parallel. It is a 1. And therefore we have cosine x over sine x. Right, at this point, we proceed to simplify these. What do we do now to simplify these here? So you cancel this out. Cosine times cosine is cosine squared divided by these. And therefore, what we're left with here is what? It's only 2. And the answer is only 2. And we're done. The answer is only 2. And we are done. So we had to determine the value of the flow expression. And we converted the tangent squared of x to sine squared over cosine squared. And the tangent of x to sine x over cosine x. And went on to manipulate, and we got 2. Okay, let's proceed and try more problems. Okay, let us simplify the flow expression. Simplify. Right. Simplify 1 minus cosine squared of a divided by 4 cosine of 90 degrees plus a. Then solution to this. What is the first step to simplify these? What is the first step in simplifying this expression? So we have 1 minus cosine squared a divided by 4 cosine into 90 degrees plus a. What is 1 minus cosine squared equal to as 1 trigonometric ratio of a? Anyone? Right, we need to remember that if you, whenever you have sine squared a plus cosine squared a, it equals what? It equals 1. So you transpose this one. Which is this. So what is 1 minus cosine squared? 1 minus cosine squared is sine squared by using this squares identity. Squares identity. Pythagorean identity. Okay, Pythagorean trigonometric identity. So 1 minus cosine squared is the sine squared. So in which quadrant is 90 plus a? 90 plus a is actually in the second quadrant. In the second quadrant, only the sign is positive, so that cosine is negative, but it's a cofunction change. By the COCO rule, if there's cosine, we remove the co, and it becomes sine, but negative. The sine of a. So the sine of a. And that is the answer. So, and this is the simplified expression. This is the simplified. Now, there's nothing more one can do at this point. There's no further simplification that is available here. So we're done with the simplification, but there's something else we need to do, okay? Here's another question. So the question says, hence determine the general solution of 1 minus cosine squared of 2x divided by 4 cosine, 90 degrees plus 2x. Zero point 21. Okay, now you need to determine the general solution of this one. What do we do here in finding the general solution of this one? Right, so we look at the solution to this. Right, in looking at the solution to this, there are a couple of things to consider. So if you have 1 minus cosine squared of 2x divided by 4 cosine of 90 degrees plus 2x, which is 0.21. Okay, so this thing here becomes minus 1/4 sine A. Minus 1/4 sine A is 0.21. Minus 1/4 sine A is 0.21. Right, and we need to proceed to find the general solution of this, and to find the general solution of this, we proceed as follows. We cross multiply anyway. Let me see what we've done here. Well, obviously we got that this was minus 1/4 sine A, but at this point you can see that we had cosine squared A, and this was 90 degrees plus A. And this one is 2x, so which means therefore this one here is going to be 2x. It's going to exactly be 2x. We cross multiply. Okay, 4 times these with the negative is minus 0.84. Like so. Decimal point or decimal comma point. Right, so we're going to proceed to find the reference angle. The reference angle becomes arcsine. Which is 57.14 degrees. 57.14 degrees. Now we need to analyze this and see that at this point, in view of the cast diagram, we have that the sign is negative in 2 quadrants, so it is certainly negative in the third and fourth quadrants, because the sign here is negative 0.84. So this angle is going to sort of take us to those 2 angles, meaning we're going to say 2x. Okay, now it's going to be 180 plus to get here. 180 plus, so which is going to be 180 degrees, 57.14. Okay, let's put a point. Plus k times 360 degrees. Or now you can consider the other one in this other quadrant, which is going to be exactly 360 degrees minus. Or 2x is 360 degrees minus 57.14 degrees plus 360 degrees by k, where k is in z. Which means 2x. 180 plus 53 plus 57.14 is actually the same as 237.14. 237.14 degrees plus 360 degrees k by k, or now we have 360 minus 57.14. So this is 2x equal to, this one is going to be 302.86. 2x is 302.86 degrees plus 360 by k. K is an element of the set of integers. Right, I divide through by 2. You divide 237.14 by 2, you get 118. (180 degrees by k). (151.43 degrees), which is 180 by divided by 2, 360 divided by 2 is 180 by k, where k is in z. Okay, so these are the answers. Okay, so now we have to find a general solution of this particular problem here. And to determine the general solution of this particular equation, 1 minus cosine squared 2x divided by 4 cosine into 90 degrees plus 2x, which equals 0.21. We started with this problem here and realized that because it was saying hence, And therefore, we know from the previous calculation that 1 minus cosine squared A, all divided by 4 into cosine of 90 degrees plus A is minus 1/4 sine A. So this one is going to be minus 1/4 sine 2x, which is this. Okay, cross multiply, which is minus 0.84. So now the reference angle therefore becomes arc sine of 0.84, which is 57.14 degrees. So, and 180 plus 57.14, which is 237.14 divided by 2, which is 118.57 divided by 2, divide 360 by 2, it becomes this. So this is the general solution to the equation. Right, so we proceed now to solve more problems here. Let us continue to solve more problems. Let's look at the next question. We have the next question right now to solve. Let's check this one here. Right, so at this point, if you have the following. So this is sort of question 5. Right, so let's look at question 5. And looking at question 5, there are a couple of things that remain very important. P minus 8 T is a point. With OP equals 17 units. Okay, we continue. Now in reflex, right, in reflex, angle XOP, which equals theta. So now I want to find the value of T. Want to find the value of T. Let's look at this. So if you have this here, right, so you have P with coordinates minus 8 and T. $17. Theta, this is Y and this is X. And this is the diagram. And here comes the question. calculate in 5.1, we're saying calculate the value of t. Calculate the value of t. Okay, I want to find the value of this t. Anyone? What is the value of t here? What is the value of t? What is the value of t? Okay, I want to find the value of t, and to find the value of t, there are a couple of things you need to consider. We can perform a construction as usual. Right, perform a construction like this, we're able to see our x and our y. And we're able to note that our x is -8 and our y is t. So that in the end, to find the value of t, we use what we call Pythagoras theorem. Pythagoras theorem. And to use Pythagoras theorem to find the value of t, we use x squared plus y squared. X squared plus y squared is actually equal to r squared. So we're going to use x squared plus y squared equals r squared. And we continue to solve this problem in a step-by-step fashion. And at this point, we actually have something to sort of realize that we have the triangle that is sort of this way. Right, and this here is a -8. Rather, the x is -8 and the y is t, and that is 17. -8t and 17. -8t, then 17. Right, using Pythagoras theorem, we're able to see that our x is -8 squared, the y squared, and the r is exactly 17 squared, which means t squared. T squared is exactly 17 squared minus 64, because that's what this is. And if you square these, you're getting 225. Right, and now you have t squared equals 225. You have the square root of t squared here, which is plus or minus the square root of this. Which is plus or minus 15. But now let's check here. T must be on this side, and therefore it's the bottom side below the origin, and therefore t must be negative. So it must have a negative value, minus 15. Hence, t is minus 15. T is minus 15. Right, from the diagram now, I want to find cosine of minus theta. Find without using a calculator. Find without using a calculator. Right, we have cosine of minus theta. So, which is 5.1. 5.2. Okay, 5.2. If this is 5.2, then we shall call this one here 5.2.1. 5.2.1, which is so look at the solution to this. So let's look at 5.2.1. What is cosine of minus theta? In which quadrant is cosine of, in which quadrant is minus theta? Zero degrees, 90 degrees, 180 degrees, 470 degrees, 360 degrees, and if this one here is minus theta. So if this is minus theta, so you can see therefore that this minus theta is in the fourth quadrant, and by the cast rule, in the fourth quadrant, the cosine is positive. So let us check now. So cosine of minus theta is just cosine theta. And if this is the angle theta, then how do you find cosine? Because you already know t. And we found t to be minus 15. T is minus 15. So that now if you want to find the cosine of the angle theta here by SOHCAHTOA, is opposite of adjacent. Rather, it is adjacent of hypotenuse. The cosine of theta is adjacent of hypotenuse, which is actually minus 8 over 17. Adjacent of hypotenuse, which is minus 8 over 17. So that is the cosine of minus theta. And so continue to analyze this question, but to analyze this question step by step. And do a lot of things. And what are the things that we are doing here? We now proceed to solve the next problem. We're interested now in finding the solution to 5.2. This was 5.2.1, and the next one is 5.2.2. 5.2.2, and you have 1 minus the sine of theta. Yeah, let's look at the solution to this. so that we have 1 minus the sine of theta. What is sine theta from the diagram? Sine is opposite of hypotenuse here. Opposite of hypotenuse. So if you have opposite of hypotenuse, the sine is minus 15 over 17. So katoa. So which means the sine is actually minus 15 over 17. Which is 15 out of 17. So we have this, and we just need to add these things here. So if you have 1 minus the sine of theta, which is 1 plus 15 out of 17. Out of 17. 17 divided by 17 is 1, by 17 is 17. Okay, and also a 15. What is 17 plus 15? Is 32 out of 17, which means therefore 1 minus the trigonometric sine of theta is 32 out of 17. Okay, we have a set of nice questions here to solve. Let us solve these trigonometric questions. Okay, this one was a 5.2, and this one is going to become like a 5.3. We continue to say if the sine of 17 degrees equals A without, okay, without using a calculator, express the following. In terms of A. Five point 3.1. Here we shall express the tangent of 17. Right, so here in 5.3.1, five point 3.2, (107 degrees). And then we have 5.3.3, which is cosine squared. 253 degrees plus the sine squared. 557 degrees. Let's look at the solutions to this. So if the sine of 17 is A, without using calculator, express the following in terms of A, the tangent of 17 degrees. The tangent of 17 degrees. Right, so we're looking at 5.3.1 solution. We want to find the tangent of 17 degrees, but we know that the sine of 17 degrees equals A, and okay, so if this is 17 degrees, the sine is going to be like opposite of hypotenuse. And it remains to just find this other side here. And to find this side, we use Pythagoras theorem. X squared plus y squared is r squared. Which means that you have the y squared, which is a squared, 1 squared, which means x is going to be plus or minus. The 1 squared is 1 minus a squared. But obviously, because x is on this side of the origin, on the right side of the origin, x therefore is only the positive square root of 1 minus a squared. So the tangent of 17 is what? So the tangent of 17 is therefore the same as. So we're going to use SOHCAHTOA. SOHCAHTOA, so that at this point, the tan is opposite, is actually the tan is opposite of adjacent. Opposite of adjacent, which means with opposite over the adjacent side, which is 1 minus a squared. Like this. Okay, so that is what we get exactly. And we found the tangent of 17 degrees. And if this is the tangent of 17 degrees, we continue to solve more problems. And in solving more problems, we find the following. Right, we're looking at 5.3.2 now. The sine of 107 degrees in 5.3.2. So the sine of 107 degrees. And we look at the solution to this. What is the sine of, okay, how can you reduce 107 degrees, anyone? How do we reduce 107 degrees? So look at the solution to this. Okay, we're going to use reduction formulae to simplify this. And we're looking at 5.3.2. We have the sine of 107 degrees, which is actually the trigonometric sine of the following, which is exactly 90 degrees plus 17 degrees. In which quadrant is 90 plus? 90 plus is in the second quadrant where the sign is positive, but it changes to its co-function so that we get cosine 17 degrees by the COCO rule. Looking at the triangle we have, we're looking for the cosine of 17. The cosine of 17, according to the SOHCAHTOA mnemonic, cosine is adjacent of hypotenuse, which is adjacent of hypotenuse, the square root of 1 minus a squared over 1. over 1. And if you divide this by 1, it is actually the same as 1 minus a squared. Which means the cosine of 17 is the square root of 1 minus a squared. Right. And we have solved this particular question, and we proceed to solve more problems. Now, in solving more problems, look at the next question, like your 5.3.3. We have the cosine squared of 253 degrees plus the sine squared of 557 degrees. So we proceed as follows. 5.3.3. Right, so we're gonna right now look at 5.3.3. Cosine squared of 253 plus the sine squared of 557 degrees. So then becomes, we have the cosine here of 180 degrees Okay, you can use, let me see, that's 180, 270 minus 10 is 260. Okay. See? Okay, there are a couple of ways, obviously, to do this particular question here. The 253, you can use 270 minus 17. Try that. So here, if you use 270 minus that, because if you say 270 minus 10 is 260 and then minus 7. Okay, so the 557 degrees, first you can write it as 360 degrees plus something, okay? Just look at this. So at this point here, if you have (360 minus 557), which is 197. 197 degrees. In which quadrant is 270 minus 270 degrees minus is in the third quadrant where the cosine is negative, but it changes to its cofunction, the sine of 17 squared plus 360 plus is in the first quadrant where all the functions are positive, all the trig functions are positive, and therefore this becomes the sine squared of 197. You square this, which is the sine squared of 17 degrees. And what then do we get out of these here? Then we have exactly the sine squared of this one, 197, and therefore that is 180 plus 17. Plus, now 180 plus is in the third quadrant in which the sign is negative. So, which is sine squared. And therefore, minus the sine of 17 degrees, which is the sine squared of 17 degrees. So these are like terms. So sine squared of 17 plus sine squared of 17 is 2 sine squared of 17 degrees. Okay, what is the sine of 17 degrees from the diagram? Let's check. We know that sine of 17 degrees is A. The sine of 17 degrees is A. So we're going to have it here. So okay, so this equals 2a squared. Okay, so yeah, 2a squared. Two a squared. So we continue. We continue. Right, because obviously at this point, we note that we had to deal with this particular question and solve this particular question, and we have done exactly that. We have done exactly that. So we had to determine, according to this instruction, if the sine of 17 degrees equals A without using a calculator, express the following in terms of A, the tangent of 17, the sine of 107, etc., etc. And we've done that. Okay, so in the next case, we need to simplify. Right, so we're looking at the next question. Let's call it 5.4. In 5.4, we need to simplify. Without a calculator. Can use words like simplify without using a calculator. Without using a calculator. Without using a calculator. When we have cosine of minus 225 degrees. The sine of 135 degrees. Plus the sine of 330. Divided by the 10 of 225. Okay, so to deal with this one, we need to simplify without using a calculator, and we proceed to simplify this without using calculator as follows. We look at the solution to this. And the solution to this is a very interesting one and fairly straightforward. So we have the following. So that we have the cosine of minus 225 degrees. The sine of 135 degrees. The sine of 330 degrees. Divided by the tangent of 225 degrees. So now, if this is the case, let us look at this and simplify together. First and foremost, the cosine of a negative angle is actually the same as the cosine of a positive angle, first and foremost, of the same magnitude. Right, the 135 is the same as the trigonometric sine of 180 degrees minus 45 degrees. 330 degrees is the same as the trigonometric sine of 360 degrees minus 30 degrees. And this, the denominator is the same as the tangent of 180 degrees plus 45 degrees. So this is 180 degrees plus 45 degrees, which is 225 degrees. Which is the, okay, let's just deal with this one. Okay, at this point, if you're looking for the sine of 180 minus theta is in the second quadrant. In the second quadrant, the trigonometric sine of theta is positive, and therefore this becomes just the sine of 45 degrees. Okay, and then now 360 minus is in the fourth quadrant, in which the sine is negative. (180 plus 45 is in the third quadrant, in which the tan is positive. So 180 plus is actually in the third quadrant, in which the cosine is negative. So this one is going to be minus cosine 45. Minus cosine 45 degrees. And this one is actually the sine of 45 degrees. Minus sine 30. Divided by the tangent of 45 degrees. Right, so now we can see the use of a series of special triangles. Let us recall some of these special triangles. 45 degrees, 45 degrees, the square root of 2, 1, 1, and you have this. In the square root of 3, 1, 2, 60 degrees, 30 degrees, the square root of 90. So right now, if you have the cosine of 45 degrees by SOHCAHTOA, Right, by SOHCAHTOA, we then have the following. Right, the cosine of 45 degrees by SOHCAHTOA, cosine is adjacent over hypotenuse at 45. And if this is 45, adjacent over hypotenuse is 1 over the square root of 2. So yeah, that's what we got. 1 over the square root of 2. The sine is, if this is 45 degrees, even this one, you can use any of these pair of any of these 45 degree angles, and choosing this one, maybe, okay, yeah, this one, opposite of hypotenuse is 1 over the square root of 2. So the sine of 30 degrees, right, 30 degrees, the sine of 30 degrees is opposite 30, which is 1, hypotenuse is 2. Sine of 30 becomes 1/2. The tangent of 45 degrees becomes opposite of adjacent, which is 1 over 1. Okay, so we multiply this, it's minus 1 out of 2, minus 1 out of 2. Minus 1 over 2 out of 2, minus 1 out of 2 is minus 1. So the result is minus 1. So obviously we need to note what we had to do here, because we were given this particular expression to simplify without using a calculator. And we took into account cosine of minus 225 degrees times the sine of 135 degrees plus the sine of 330 degrees, all divided by the tangent of 225 degrees. And we have simplified it. And we have this. And then we have minus 1. Next question. Next question. Proof. Right, you need to prove. Cosine x plus 1 into cosine x minus 1. And you have 1 over. And we have to prove that this here is actually the same as minus 1 over 10 squared cosine squared. If there's solution to this. Okay. So now need to prove this. Right, to prove this, there are a couple of things you need to consider. Right, to prove this, now we proceed as follows, and we take the left and we take the right, and we compare. Right, let us take the left-hand side. So let the left. 1 divided by cosine x plus 1 into cosine x minus 1. The left-hand side is 1 divided by, okay, if you open up the brackets, cosine x by cosine x, this is like a difference of 2 squares. Right, if this is like a difference of 2 squares, we get the following quickly. Setting out the connection to boost up the battery. We boost up the battery power, and we have the following. Okay, we have the following here. So which means we get that in the denominator, we have the difference of 2 squares being factorized. So which means cosine x by cosine x is cosine squared. Cosine x by cosine x, cosine squared, cosine x by -1 is minus cosine x plus cosine x. This and this is -1. Right, so obviously looking at the denominator, we're able to see that minus cosine x and cosine x give us 0, so that we are left with cosine squared -1, and therefore the left-hand side. Which is cosine squared x -1. Which is 1 minus cosine squared x. 1 minus cosine squared x is the same as sine squared x. And hence the left-hand side is -1 over sine squared x. Then we look at the right-hand side. What is the right-hand side? All right, the right-hand side is actually -1 over cosine squared x. Which means the right-hand side is which is sine squared x over cosine squared x, and we have cosine squared x. So at this point, because it is very clear that if you have something like this is out of 1, and this cancels out, and we are left with -1 over sine squared x. So hence the conclusion is the left-hand side is the right-hand side, which is -1 over the sine squared of x. We continue now to solve more problems. So, okay, at this point we had to prove that this equals this. And to prove that those two are equal, we have demonstrated that. We have most certainly demonstrated our power to prove this. And we're done. Okay, next we look at the next question. determine the general solution for true sin x times cosine x equals cosine x. And look at the solution to this in a step-by-step manner. So let's look at the solution to this. So if we not determine the general solution for 2 sin x cosine x equals cosine x, we proceed as follows. Which means you have 2 sin x cosine x, which equals cosine x. 2 sin x cosine x minus cosine x equals 0. And therefore, this is cosine x as a common factor. And we want to find the general solution here. So cosine x, a common factor, we have 2 sin x minus 1. And then we have the cosine x into 2 sin x minus 1 equals 0. Which means cosine x equals 0. Or at this point, we want to find the sine of x, which is 1/2. Which is exactly 1/2. So what is this? And I want to find the solution right now to this. What is the solution to this? So obviously, there are a couple of things. When is the cosine 0? Right, there are 2 places in which the cosine itself equals 0. But first, we find a reference angle. Right, the reference angle would be actually 90 degrees. Right, which means the reference angle here is 90 degrees. Or here we find a reference angle, which is arc sine of 1/2, 30 degrees. Okay, so if you look at this diagram and you look at the cast rule, you're able to see that the sine is 1/2 in 2 places. It's positive, right? It's positive in 2 places, in the first and the second quadrant, which means x is going to be in the first place 30 degrees plus 360 degrees times k, where k is in z. And in the other place is 180 degrees minus 30 degrees plus 360 degrees by k, where k is in z. 180 minus 30, which is 150, plus 360 degrees times k, where k is in z. Okay, now you also look at the 0 here, meaning when is the cosine 0? It is 0 at the 90-degree angle, but also it is 0 there. So, which means therefore that x at this point is 90 degrees plus 360 degrees times k, where k is in z, which is 270 degrees plus 360 degrees times k, where k is in z. Okay, so these are the two answers that we have. These are the two answers that we have. Or the two separate solutions, but yeah, a set of four, sort of. A set of four solutions, and we have solved this particular. And this actually constitute what we call the general solution to the trig equation. So we actually looked at this one, determine the general solution of this, and we tried to do this, and we transposed the cosine x to the left. We took out the highest common factor, the HCF, which is cosine x, and we have actually obtained 2 sine x minus 1. Cosine x is 0, or sine x is 1/2, and we have this. And we have that exactly. We continue. We continue. Right, so in continue, we solve more problems. And we solve more and more questions. Okay, we solve more and more questions as we shall continue, and etc. etc. Okay, let's look at more problems. And look at more problems now. I want us to diversify. We'll spend a reasonable amount of time looking at some equations. Let's look at more equations. Let us look at more equations. Okay, so we continue. Right, we continue. So now in continuing, we solve, but let's solve some equations and some inequalities. Let's solve this inequality here. Here we need to solve. X squared minus 2x minus 8 is less than 0. And look at the solution to this. We have x squared minus 2x minus 8 is less than 0. Right, to factorize this, to multiply x squared by minus 8. And if we do that, we get minus 8x squared. Look for the factors of minus 8x squared that give minus 2, which are minus 4x into 2x. So which is minus 4x plus 2x minus 8 is less than 0. X into x minus 4 plus 2 into x minus 4 is less than 0. X minus 4 is a common factor, then we have x plus 2 is less than 0. X minus 4 into x plus 2. Right, is less than 0. We find the critical values. Which means x is 4, x is minus 2. Right, a quick way to quickly reason the solutions out here. Minus 2, 4, x-axis, this one. And we're looking for where parts where the quadratic itself is negative. It is negative below the origin, or rather below the x-axis, and therefore that is when minus 2 is less than x, less than 4. Okay, now there are a couple of things we need to also look at. Let us look at these particular equations here. We need to solve for x. Right, we need to solve for x. So to solve for x, we proceed as follows. Solve for x. Right, in solving for x, number one, we have the following. We have the following. Right. So what do we then have here? We have number one, right, x squared plus x minus 12 equals 0. So now to solve this, we need to first multiply x squared and minus 12. Which is minus 12x squared. Look for the factors of minus 12x squared that gave x when added. 4x into minus 3x, which is x squared plus 4x minus 3x minus 12, which means it is x plus 4, which is plus 4 here. We pull out the highest common factor of the last two terms. Right, x plus 4 now is factorized, and you have x minus 3. And therefore, we have that x is minus 4, or x is 3. So we continue. We continue. So we solved for x there. But we continue to look at more problems. We continue to look at more problems.
Yes, I'm still here.
Oh, you're still here. Okay, I'm excited. Yeah, thank you for being there. Part 2 next. Some people may be left and they're exhausted. Okay, number 2. Let us look now at problems that involve radicals, called radical equations. So if you have, for example, 2x plus 1, which equals x minus 1. How do we solve for x here? Look at the solution to this particular equation. So how do we solve for x here? Okay, so to solve for x here, we have 2x plus 1, which is x minus 1. You square the left, and you square the right, and you square the left. 2x plus 1, and if you square this one, it becomes x squared. X by minus 1 times 2 is minus 2x when you have this one. Okay. So you have this one brought across, which is minus 4x, which means x is minus 4 equals 0. X is 0, or x is 4. So you need to test this. All right, testing this is quick to see that if you put 0 here, it's going to be 0 minus 1, which is minus 1. So, which means that this one is invalid. But now x equals 4 is going to become 3 here, and this one is going to be exactly 9. So this one is valid, but this other one is invalid. Now, number 3. Two to the power. Okay, now, next we look at more problems that involve certain radicals. Certain radicals. So, for example, if you have 2 to the power x, the square root of x, which equals 2 to the power 27. Okay, the bases are the same here, and look at the solution to these to solve for x. So, which means that now if you have 2 to the power x into the square root of x, which is 2 to the power 27, with bases are the same, the exponents are equal, which is x, that which is 27. Right, so now we need to proceed to solve for x here. And in solving for x, then we proceed as follows. Right, solving for x, we proceed as follows. This x and that can be seen as x times x to the 1/2 equals 27. So x to the power 1/2 equals 27. Here it's to the power 1. 1 plus 1/2 is 3/2 to the 27, which is 3 to the power 3. So x to the 3 out of 2, you raise it to 2 out of 3. Okay, you raise it to 2 out of 3 so that at this point 3 cancels, 2 cancels, and 3 cancels, and we have 3 squared, and 3 squared is 9, and that is the answer. So given the equation x to the power 2 to the power x, the square root of x, 2 to the 27, we have solved for x. We have solved for x. Let's look at the next question. Let's look at the next question. Right, so look at the next question. There's a couple of things you need to consider. Let us look at simultaneous equations. Right, we're looking at simultaneous. Simultaneous, okay, equation. Let's just say, okay, we are saying here solve for x and y simultaneously. Solve for x and y simultaneously. Yes, please. Okay, just give me a few minutes, please. All right, solve for x and y simultaneously. Solve for x and y simultaneously when you have x minus 2y, which equals minus 3, and xy equals 20. So we have x equals 2y minus 3 and xy equals 20. Put 1 into 2. If you put 1 into 2, wherever there is x, you put 2y minus 3. Two y minus 3. Y equals 20. Minus 3y minus 20. Right. Now we have this, and we want to solve this for x and y simultaneously. So to solve this for x and y simultaneously, we proceed as follows. We multiply 2y squared by minus 20. And if you do that, you get a minus 40 y squared. And therefore, look for the factors of minus 40. That will actually give a minus 3. And those are minus 8, y, and 5y. So that you have 2y squared, and then you put here minus 8y plus 5y minus 20. 2y is y minus 4. Okay, pull out 5 here, and it becomes minus 4. Y minus 4 is a common factor, and you have 2y plus 5. Which means, therefore, y equals 4, y equals minus 5 over 2. But we have that x is 2y minus 3. X is 2y minus 3, which means x is 2 into this minus 3. Or x is 2, y is minus this minus 3, which means x is 8 minus 3, which is 5. Which is 2 cancels and giving us minus 5 minus 3, which is minus 8. Whenever x is 5, y is 4. Whenever x is minus 8, y is minus 5/2. Okay, so these are sort of the solutions. Let's look at another question here. This one, you need to simplify something very small. Simplify. Right, so we need to simplify given the following. So obviously we simplify without. Without using a calculator. X plus 2x minus 1. And this is x minus 2x minus 1. And we present the solution to this. Right, as follows. All right, so if you look at this now, to simplify this, we proceed as follows. We put a big square root, multiply what is under the square root, like this. Multiply this with that, x by x. Okay, this is like a difference of two squares. So in the case of a difference of two squares, you multiply x by x. X squared, you multiply this by this. You get minus into 2x minus 1. Which is minus 2x minus 1. So it's going to be plus 1. Okay, so right with this, then we're able to have the following. X minus 1 all squared. And the square root of this is the modulus of x minus 1. The square root well, this is true since in mathematics, the square root of x squared is the modulus of x, and the modulus of x, or this is called the absolute value. Absolute value of x, which is x minus x. X greater equal to 0, x less than 0. Like so. Right, so let's look at these now and look at these very, very carefully. Let's look at these now and look at these very, very carefully. So that is sort of the answer. So we had to simplify this and went through the steps and we simplified it step by step and got to this answer. So I must thank you guys for joining us. I'm going to see you guys tomorrow at 4 p.m. I'm organizing another lesson tomorrow at 4 p.m. So be ready that we meet tomorrow at 4 p.m. and we do more mathematics. And so we therefore obviously are ready to continue tomorrow at 4 p.m. Sunday is tomorrow at 4 p.m. and we're going to solve more problems and more mathematics. So thanks everybody for joining us and a very goodbye to you.
Bye-bye, sir.
Goodbye, guys. And I'm going to send you the stuff later on, or at least by Monday, latest, the timetable, Tenula. Okay.
Yes, sir.
All right. Good, guys. And goodbye to you and goodbye to Pekhalelo as well. Goodbye.
Bye, sir.
Goodbye, guys.